Okay, so let's learn things about the tangent.
I'm great, excited.
I'm greatly excited.
Okay, so I think I have here a circle that's left over from somewhere, where I had a theta and a 1 and what was
sine and cosine? That's cosine.
this bit here is cosine of theta,
So true.
and then this bit here is
Sine of theta.
sine of theta, which I'm not going to write in there right now because I don't want to clutter my picture up.
That's okay.
Okay, what did I tell you guys about where the tangent lives?
What do you tell us?
On the outside. of
Okay,
the
so draw yourself a tangent line, like so, and then extend. This distance here is tangent of theta. Alternatively, tangent of theta can be defined as
sine over cosine.
sine of theta over cosine of theta. And then you guys all know this goes with the TOA part, right?
Yes.
Which is spelled
TOA.
TOA. Wait. How does that work? Because this is the so part.
Yeah. Yeah, so that'd be the opposite. And then your cosine would be the hypotenuse.
Okay, so I'm thinking
So
like
hypotenuse.
opposite
It's
over
rise over
adjacent.
run. It's rise over. It's like your slope.
It's not A over A? This is a joke from earlier.
It's your rise over. It's your rise
Thank
over
you.
run.
I was like, oh shit, did I forget something about the tangent function? Right, sine's the opposite over the hypotenuse,
Yeah.
and cosine's the adjacent over the hypotenuse.
Yeah.
Just so I'm not using 0 as a variable, right? And then how do you get this out of that?
You just can cancel out the hypotenuse.
Yeah, you flip, multiply, cancel out the hypotenuse. Hypotenuses?
I'm gonna name my
Is
next
there a plural of
album.
hypotenuse?
Canceling
So,
the hypotenuse.
this is actually a good question, I'm not sure.
I said that naturally, I didn't think of it.
Hypotenuse.
Because radii. Radii.
Hypotenuse is a possible.
Hypotenuse.
Yeah, the tangential hypotenuse.
Hypotenuses
I mean, if you think about the
is
English
maybe
language,
reasonable.
you
The
think-
other reasonable
no,
one
it's hypotenuse.
It's just hypotenuse.
When it's just-
It's already
Is-
close.
Hypotenuse.
Hypiece.
Hypotheses.
Hypotheses.
The hypothesis.
Yeah, right.
And then,
Goose geese.
Yeah. So hypotenuse, hypotenuse.
Hypotenuse, hypotenuse, hypotenuse.
Hypotenuse.
Oh,
Hypotenuse.
that's what I needed. Hypotenuse.
Yeah, I was like, that's a real, it's a real
Hypotenuse.
Right?
there.
Hypotenuse.
No? I don't know what the answer is.
I know what the answer is.
Hypotenuses.
Currently it's hypotenuse.
I don't really like that one the best.
It's the second one.
Okay, well, because math class is,
No, I
I'll
want
use-
because in math class I'm allowed to define things the way I want, I'm going to go with
Hypotenuse.
hypotenuses.
Is that going to be on the exam?
What
Yes.
about your
And if we don't write that on the test, then
What's
that's
that?
your hypotenuse?
hypotenuse and hypotenuses.
Okay, anyway, back in.
That's a knee slapper.
Okay, back in. I need to.
Just keep the video.
Yeah, no, it's fine. So what I need to do is I need to like get a graph of the tangent function, right?
Right.
Okay, so it should be relatively clear, I think, what the graph of the tangent function ought to at least start as,
A line.
right?
The sine and cosine put together. Cut in half.
Sine and cosine put together, cut in half. Okay, so if you're thinking about sines and cosines, right? You need the sine picture, which looks like this thing, right?
More or less.
And you need to divide that by the well, let me do this.
Multiply by one.
Multiply.
Over
Okay.
the
I like that.
cosine picture, which looks like this, right?
Yeah. So how many times can cosine go into the sine?
Okay, so there should be a clear problem here.
Yeah, that they're like out of sync from one another.
Yeah, so they're a little bit out of sync, which is going to make this graph interesting, right? And what's the kind of clear problem with dividing by cosine?
It's got zeros.
Yeah, cosine's cut zeros, like a lot.
So
Like how many zeros does cosine have?
twice every period.
Infinitely many. What are you going to get when you divide by 0 infinitely many times?
Error.
Fuck.
A whole bunch of badness, right?
There's a lot of asymptotes.
So there's a lot of asymptotes. In fact, there's an asymptote at every one of these
Every
values.
zeros.
What are these guys? When's cosine 0?
At pi.
Cosine 0 when this adjacent side is 0, right?
Yeah.
So if I start here, the adjacent side is 1, right?
So now you're gonna.
I crank around, whoop.
Now
That's half pi.
So I got half of pi over 2, right? So I know I'm going to have an asymptote at pi over 2.
And then at negative pi over 2 also.
And, oh, yup, at negative pi over 2.
And then that's one period right there. So that's what
Every,
we build.
every 2 pi.
And then every,
Every half.
Every pi.
Every half pi.
okay, so where's the next pi over 2 from pi over 2?
3 pi over 2.
No.
So it's every pi.
Where's the next pi over 2 from pi over 2?
Pi.
Oh
Is
my
that
gosh,
pi?
Pi. Half of pi plus
Right?
half of pi is a whole pi.
Is pi causing problems with cosine?
No.
What's cosine at pi?
1.
1.
1. Are you allowed to divide by, well, it's negative 1. Are you allowed to divide by negative 1?
Yes.
I hope so.
Yeah,
So it's
sure.
going to be every pi after that.
So it's every
pi over 2.
pi on the pi over 2.
Yeah, so you get 3 pi over 2.
You guys see that? So this next problem will be out here at 3 pi over 2.
Yeah, so
Right,
from,
that'll be whoopsie
So-
right there.
from pi over 2, it's an additional pi.
Yep.
Not
So-
from origin, it's from pi over 2.
Exactly. Right. It's every pi starting at pi over 2 and going in both directions. You guys with me on that?
Yeah.
Because you can't have tangent of
And then it like, so then like slides into the.
Yeah, so the issue with the issue is really like, if I think about it this way, right? You guys see that? If I'm kind of pointing, where's my stick?
You have that.
Okay, so right here,
Yeah.
what's the tangent?
Tangent. 0.
0. Okay. Dot at 0. Okay. As I crank on this thing, what's happening to the tangent?
It's going up.
It's going up, right? So pretty clearly it's going up. Is it going up?
Slow.
Starts slow and then speeds up. and then-
Starts slow and then speeds up,
Speeds
right?
up towards that.
So it's going to look something like that, maybe?
Yeah, something like that.
And the same thing off.
And then if I go down, right, it's going to be
Same
It's
thing.
the same thing.
Just kind of reflected across the y.
it's going to be the same thing but negative, right?
Right.
Okay, so I get something like this, right?
Yeah.
And then what happens when you're getting close to 90 degrees?
It's getting really, really big.
Yeah, so like right here, it's getting big fast, right?
Yeah.
Yeah.
If I go just a little bit further, it's going to get a lot bigger, right?
So just
What-
shift it.
Now, you can't now.
You can't have that, it's
You
undefined.
got a problem.
Now it's asymptotic.
Yeah, because those are two parallel lines, right?
Yeah.
Parallel lines.
Okay, so
There's-
those aren't going to meet, hence the tangent value doesn't, or the tangent function doesn't have a value associated to pi over 2.
It's a set with nothing in it.
You guys see that? So I'm going to get vertical asymptote here, vertical asymptote on this side for the same reason.
And that's because there's division by zeros?
And that's because there's division by 0.
Good. Can we, I mean, we know it, but can we prove it? By
What?
algebraically?
Can we prove?
That we're dividing by 0 when you get to like pi over 2?
Yeah, because the cosine, right, is 0 there.
Right, okay.
So,
And then, yeah. and
On the
then
one
sine over
hand, I can
cosine
think about it as
equals 0.
this line and that line aren't going to meet,
Right.
right? And on
And
the
then
other hand, I can
mathematically-
think about it as a ratio between sine and
Sine
cosine,
is
and
whatever,
cosine
cosine
0.
0.
I was actually, I'll cross your line.
Okay, so, question. What does it do in here?
Same thing.
It's exactly the same.
Same thing?
Yeah. Yeah.
I agree with that.
Okay,
It's agreeable.
now, hang on a tick, because when I went over here, right,
Yeah.
what value is it getting?
Right there should be.
It's going to get,
It's getting a really big negative value, right?
Yeah.
How does that relate to this line over here?
as you're going
Flipped
down,
over the,
it's flipped over the
the
axis.
y-axis.
So you just remove, so you just take that line and put it over this side.
Take that line, put it over here?
Yeah.
Shouldn't I get a really big positive value then?
You do get a, no you don't. You get a really big negative value.
No, your marker goes all
Right,
the
you're
way
thinking like this
in
way,
both
right?
directions.
Yeah. follow that back down here.
Yeah, there you go.
It's close.
That's what I'm trying to say.
You guys see that? So it is where that angle hits this line, right? But you think about it as a line, not as a ray.
Cool.
Right, so instead of thinking about it as this way, okay, I really should be thinking about it this way.
Lines go both directions when you origin at the same time.
Yeah.
Infinitely.
Cool? Questions there? Okay, so what's the period of tangent?
Pi.
It's like,
Seems like it's pi wide before it repeats, right? Okay. What else do I know about tangent? What was the other thing we learned a bit ago?
It's odd.
Tangent's odd.
Tangent is odd,
So vertical
which
flip
means that a vertical flip
is a horizontal flip.
should be a horizontal flip.
And that's true.
And that seems true. Cool. Questions there?
Absolutely.
Okay.